Okay, here it is as promised. We're gonna go through some of these examples that'll help you with the Pear Deck, and talking about what we talked about mostly in yesterday's class on Thursday. So the main thing we did yesterday, compounding continuously, it's a little different. It just means that it's compounding theoretically in an infinite amount of times. Like over here, this is a finite amount of times, like twice a year, 4 times a year, 12 times a year, whatever. And is here, it's compounding continuously, so theoretically infinitely. So the only time you would use this is if the problem says it's compounding continuously. That's the only time you're using this guy. Every other time says compounding annually or monthly or whatever. That's this. This is the only time is continuously. That's it. If you don't see continuously, you're not using this one. Always just go to this one until you see the word continuously. That's when you can hop over to this one. So when this one says 20,000 growing at a rate of 1 3/4%, compounding quarterly for 20 years, compounding quarterly. So that's here. Only use this when it says continuously. So all you're going to do is write these guys out, F, P, R, N, and T. Future value, well, that's what we're looking for. We're solving for future value here. Should be used to this, been doing this all week. So we're looking at 20,000 for the original amount. The rate as a decimal, 0.175. Remember, we're converting that rate to a decimal, so its decimal is going to slide over twice. And that's how many times it compounds a year. When it says quarterly, that means 4. And the time is 20 years. So all we got to do is go to the formula, plug those babies in. 20,000 times 1 plus the rate, 0.0175, divided by n, which is 4, to the 4 times 20. Okay, and then we'll just toss that into a calculator. So we got 20,000. We'll write that out, open parentheses, 1 plus 0.0175. And when you want to divide, you use the backslash. It's the same as the question mark button. And then divide that by 4. In order to get out of the fraction, you have to hit the over button. So you can close parentheses. Shift 6 is the caret, puts you in the exponent. You got to open parentheses so that they both stay in there, and say 4 times 20. There we go. 28,359 and 69 cents. There it is. Okay, over here, it's the same thing except, okay, 20,000, 1 3/4% for 20 years. It's compounding continuously. That's the only difference. So we're going to use all these same numbers, but we're using this formula because it's compounding continuously. N doesn't exist anymore over here because it's technically infinite. So we're talking 20,000 times e to the rate, so 0.0175, times the time, which is 20. So we'll toss that right into a calculator. We see 20,000 times e. It knows that number. It knows it's a mathematical constant. And then to the RT. So we'll open parentheses and say 0.0175 times t, which is 20. And there you go, 28,381. And you can see it's a little bit more. It is a little bit more than compounding quarterly because it's compounding more often. So it gets more chances to grow on top of the interest it's already earned. So yeah, the compounding continuously, it's going to be a bigger number here if we're looking for the future value. So there you go. That is compounding continuously. This will be compounding quarterly there, or any finite number, you just change n. So we could solve for different things, though. We talked about that on Thursday. In this case, we're going to solve for the present value, the principal, or the initial value. So you'll see some like this. Over here, it says, I made a one-time investment 17 years ago. So 17 years. It earned 3.5% compounding monthly. And then the balance is now 32,150. What was the initial investment? So this is compounding monthly. Of course, we're going to use the regular compounding in a finite way formula. So we will list these babies out. So 17 years. It's compounding monthly, so that's 12 times a year. The rate was 3.5% as a decimal is this. Let's see. The present value, we don't really know. The initial value, the principal, we don't know that. But we do know after 17 years that now it's 32,150. So we're actually solving for P this time, and it's going to take a little bit of solving skill. So when we plug these in, we're looking at 32,150 equals P times 1 plus 0.035 over 12 to the NT. So 12 times 17. Okay. This is just like if we had something like 15 equals P times 3. Okay, this is just a number right here. This number, you could plug it into a calculator and it'll give you a number. The problem is it's going to be a crazy number. It's going to be 1.0765789, and you're not going to, you won't be able to write it. So what we're going to do is just treat that as a number itself. So like up here, exactly how you would divide by 3 to make that 1. Divide by 3 to make this 5 and say that P equals 5. Exactly how you would solve a little simple equation like that is how you're going to solve this one. So we're going to just say, since it's P times this, let's just divide by that. And we're going to divide that over here too. 1 plus. So anything divided by itself will be 1. So this thing here, right, is being divided by itself. So that means that is 1. And 1 times P is just P. So we're left with P equals, and then whatever this is, right? We're going to have to toss that into a calculator. So let's look at how to toss that into a calculator. You type in the 32,150, you hit the divide button, the backslash, and then we can open parentheses and say 1 plus, okay, it was 0.035, so that was the rate. We're going to divide that by n, which was 12. Then we hit the over arrow to get out, close the parentheses, shift 6, the caret to get into the exponent. And what was it here? 12 times 17. So 12 times 17, close parentheses, and there you go. 17,748. So what does that mean? That means that this amount was what was initially invested, and after those 17 years, growing at 3.5%, it ended up becoming 32,150. So this was the initial investment amount. So there you go. Something very similar happens when it says compounding continuously. So again, just like the last example, I'm using the exact same numbers. So we're going to look at these numbers still, except this is compounding continuously. So we're looking at P times E to the RT. All right, so when we plug these in, we're talking 32,150 equals P times E to the RT. So R 0.035 times T, which is 17. Okay, so this one's a little bit easier, you can see, because there's not as much writing, but it's the same exact process, right? I have P times a number. E to the whatever this is going to be a number. But so we can then just divide by that, right? And E to the 0.035 times 17. Divide by that number and do it on both sides. Okay, well, any number divided by itself is just 1. So that leaves us with P equals, and then we toss that into the calculator. 17,732. Now, some might think this is a little strange, because normally we're saying, right, that the compounding continuously, we're expecting larger numbers because it has more of a chance to grow on itself. Well, we're going backwards now, right? So it takes a smaller number to get to this big number originally, because compounding continuously grows more. Versus in order to get to 32,017 years, you're going to need to start with a bigger number since it's growing not as fast. Okay, but only slightly here. You can see it's like, what is it? It's like $18, $16, something like that. Not too big a deal in that case with those small interest rates. But let's see. Last one, solving for rate. So we're always gonna, when we're solving for rate, we are always going to use the finite equation. And we're just gonna assume a yearly compounding, because that's what we care about when we ask this question. When we say what has been your average annual returns, we're referring specifically to annually. Like, what have you gotten year over year over year? So we're considering those when we ask that question. We're considering yearly. So we're just going to use this, and we're going to say that n is 1. N is 1 there. So let's fill these out again. So an investment of 12.5 30 years ago. I now have a balance of 100,000. What was the average rate of return? Well, we know n is 1 because we just decided that, because that's what doesn't specify, and that's what we're really kind of looking at. So we're going to say that future value 100,000 equals the original 12.5 times 1 plus, now r over n, if n is 1, that means it's r over 1. And anything divided by 1 is just itself. So r divided by 1 is r. And I'll just put that as an r so I don't have to write another step. And then same thing for nt. When it says n times t, well, n is 1. So 1 times t is just t. Right? 1 times itself is just t. So we're just talking about 30 right here. Okay. So we don't have to worry about those other guys. We got to solve for r. So this one takes the most amount of like solving skill here, but certainly doable. And I'll show you what's going on here. So we just got to unwrap it one step at a time, and we're going to start away from r and work towards it. And r is stuck inside these parentheses. We have to free it first by getting rid of all these other things. So just like the start of the other ones, since it's 12,500 times this, the inverse of multiplying is dividing. So I can divide that. How's that help us? 12.5 divided by 12.5 is just 1. So that gives us 1 times anything is itself. So we still have that. And then let's see, 100,000 divided by 12.5. Is that going to be a nice number? If it is, we'll switch it. If it's not, we'll just keep it. 8. Okay, it's a perfect number. Okay, so if this was ugly, you could just keep it as this divided by this. That's fine. But it's 8, so that's very nice. And then the next step, I need to get rid of this 30. So the inverse of taking an exponent is taking a root. So we make the little radical symbol on both sides. Well, what root do we need to take to cancel out a 30 exponent? We need to take the 30th root. 30th root. So this 30th root will cancel out the 30th exponent. We will get 1 plus r. No more need for the parentheses, since all of the outside stuff is gone now. The 12.5 is gone. The 30 is gone. So we don't need these parentheses. It's just 1 plus r over here. The 30th root of 8 will certainly not be a nice number, so we're just going to leave it. We'll leave it the 30th root of 8. That's fine. And then the last step, 1 plus r. If we're solving for r, we need to get rid of this 1, so we can subtract it. 1 minus 1 is 0, so it goes away. So minus 1. And you'll say that r equals the 30th root of 8 minus 1. Now, obviously, no one can do the 30th root of 8 in their head, so we're going to throw that in a calculator. Okay, let me show you how to put that in a calculator. You have to type nth root, and it'll give you the nth root. You got to type that out. Nth root. It's just saying some n is a placeholder for the number. So some root, in this case, it'll be the 30th root. But that's what you type that out, nth root, and you see it gives you a little spot up here. And that's where I can put 30. and then 8. Hit over to get out of it so that you can subtract 1. Because I'll show you what happens. Nth root 30, you hit over to get there, and it's 8. Now, if you don't hit over, you'll hit -1, and you see how it stays in there. And this is doing 8 minus 1, which is 7, and it's taking the 30th root of 7. So you don't want that. You want to be outside. You want the 30th root of 8, hit over, and then subtract 1. There you go. 0.0717. Okay? So it says then that R is 0.0717. Now, is that 0.0717%? No, this is a decimal version of a percent. Just like when you convert a percentage to a decimal by moving the decimal to the left twice, you can convert it back by moving it to the right twice. 1, 2. So that is 7.17% here. Your rate, your average annual rate, average annual return rate was a little over 7% over those 30 years, and it turned your 12,000 into 100,000. And they're pretty much all going to be solved that way. So, just kind of follow those steps. It takes a little bit of just keeping track of where the numbers are and what's going on, and making sure it's going into your calculator correctly. Yeah, send me a Google message, Google chat message if you have questions on that while you're working.